In a previous video, we defined what is the probability that a random variable takes a value. Now, in this video, we are going to define what is actually a discrete probability distribution. When we have a discrete probability distribution, we have all the possible values of a random variable. And we have all the probabilities. So if we have a value of a random variable, we know its probability. So that can be given using a graph or using a table. So for example, in a table like this or in a graph like this, when we have in the x-axis the possible value of the random variable and the probabilities are in the y-axis, we can represent a probability distribution, a discrete probability distribution. In this, for example, we have a discrete probability distribution with three values. The values are 10, 20, and 30, and the height of the rectangles actually is giving me the probability. Usually people use a rectangle or use a line in the value. The line with the height as the probability. So one option is giving you a graph, another option is giving you a table. You can make a table like this when we have in one column the value of the random variable, and we have in another column their probabilities. So for example, in this a discrete probability distribution, we have that the values are 10, 20, and 30. So this is the same probability distribution that we have here, but now in a table. So the probability of 10 is 0.6, the probability of 20 is 0.3, and the probability of 30 is 0.1. There will be some conditions, obviously, but obviously the probability distribution just show all the possible values and their probabilities. What are the conditions? Obviously, the value of the probability need to be probabilities, so that need to be numbers between 0 and 1. And the second condition must be that adding together all these values, the answer must be 1. So adding together the value of the probability. So if we satisfy these two conditions, we have all the possible values, and for sure we have the probabilities of this. If you have this condition, this is a possible discrete probability distribution. A discrete probability distribution has a expected value or a mean. And the expected value or mean is actually if we made this experiment many times, let's see, infinite number of times, the mean, sometimes we obtain 10s, sometimes we obtain 20, sometimes we obtain 30. So remember, these are the values of a random variable. So, but the mean will be the number that you obtain here. So the expected value is like the mean obtained if we make the experiment infinite number of times. So how to compute it using this formula? The formula says that the expected value of the variable x will be the sum of all these products, the products of the values and their probability. So you multiply the value of the random variable times its probability, and when you have all the product of the value and the probabilities, then you add together. For example, this value number 10, you need to multiply by its probability, that is 0.6. Of the value 20, multiplied by its probability 0.3. So it will be a good idea, for example, make another column. You make another column when you can make the products, x, px. So when you make the product here of the values and the probability, and then add together at the bottom. If you do that, the sum will be the expected value. Let's do it. So we need to multiply the value times the probability. So that's the reason I put it here. I don't want to forget what I need to do. Yeah. So multiply the value 10 times the probability. 10 times 0.6. The answer is 6. So good. Then 20 times 0.3. The answer is 6 again. So I type 6. 30 times 0.1, the answer is 0.3. So, sorry, 3. So we have 3 and the 6. So add together all these numbers, and the answer is the mean. So adding together 6 plus 6 is 12 plus 3, 15. So it means that if we make this experiment many times, the probability, I think infinite number of times, the mean will be 15. Yeah? Obviously, we cannot do it many times, infinite number of times. But we can do it many times. If we do it many times, the value of the mean will be close to this 15. Yeah? So it's good to know the expected value. Actually, we are going to know the mean of all if we run the experiment many times. Okay, so but because we find here different values, we have a variation also. If we make the experiment many times, we can get a variation. Yeah? We are gonna get a variation, obviously. So it means that we can measure this variation, and we remember that we measure the variation using the variance of the standard deviation. Let's use the variance first. Yeah? So the variance will be useful for knowing the variation of an experiment that have this random variable. Yeah? So if we make this experiment many times, the variance will be close to the number that we have here. So, and this number is computed in this way. Each value minus the mean, and the results I need to square. When we have this product here, this square here, then we multiply by the probability of the value. And we have all this product, we add together. That's what the formula said. So it will be a good idea to make another column. And let's compute the variance now. Yeah? So if we want to compute the variance, then I'm going to make another column that have the value minus the mean. And I'm going to square this immediately. So I have a calculator here. So for example, for the first value, I have number 10. 10 minus the mean, and the mean is 15. Yeah? 10 minus 15 is minus 5. And then I square, I get positive 25. Let's type it here, 25. If I want to know what is the number here, I'm going to make 20 minus 15. The answer is 5. 5 squared, again, 25. And when I do this 30 minus 15, the answer is 15. 15 squared, 225. Okay, now that I have this, it will be good to make another column. And the other column will be just what it's telling me here. So I'm going to complete these things here before making the addition. This product, the value that we have compute, x minus the mean square, that is the number that we have compute here, and I'm going to multiply by the probability. The probability is 0.6. So it will be 25 times 0.6 will be the number that is here. Yeah? 25 times 0.6. So the probability times the value minus the mean square. Okay, will be 25 times 0.6. How much you obtain? 15. So let's type 15 then. 15. Then 25 times 0.3. How much you obtain? 7.5. Okay, let's type here 7.5. And then 225 times the probability. And this is 22.5. Yes, 22.5. So adding together all these numbers, 22.5 plus 7.5, this is 30 plus 15, 45. So 45 will be the value of the variance. And this is the symbol that we are going to use for the variance. Remember, this is the same symbol that you use as a population variance in statistics. Okay, so now we have the variance. What happens if somebody asks me for the standard deviation that we know that is a useful, it's more useful for getting the dispersion of a variable. So if we want to compute the standard deviation, just remember that the standard deviation is just the square root of the variance. So the standard deviation will be the square root of this value. So we have it here. So if we want to compute the standard deviation of this discrete probability distribution, the only that I need to do is just get the square root of 45. And the square root of 45 less the square root of 45. Use your calculator to compute it, and the square root of 45 is 6.71. This will be the square. This will be the way of you one way to compute the standard deviation. So now I have finished to explain what is the discrete probability distribution, how to compute the expected value, and how to compute the standard deviation.